I'm really excited to announce that from January 2023, I'll be able to further support you with small group tutoring, intensive revision courses in the holidays, or online tutoring too. So if you find the way that I describe things useful and you'd like some extra help, then please get in touch via my website, www.cardiff-maths-tutor.co.uk. Also, if you could hit the subscribe button, that'd really help me continue to make these free videos. This is the Mathematics Unit 2 Calculator Allowed Intermediate Tier paper for November 2019. Okay, so turning the page, second page is always our formula sheet in intermediate tier, only the two formulae that we are given, so we may use them, we may not. Over on to question 1. Nice question to start off with. 12.5% of 1,176. Into your calculator is going to go 12.5% means out of 100. Okay, so that percent there means out of 100. We then change of to times and then put in the digits there. So that percentage has changed to over 100 and then of changes to a multiply. And that just simply goes into your calculator. So whatever calculator you have, you should just be able to press on. And then within here, let me just turn the light off on the visualizer, and that way then we should hopefully be able to see it a bit better. So 12.5 over 100, move to the side, times by 100 equals SD it, and I get, times by 100, sorry, I was going to say, I would have thought that should be a slightly different number, 147. So then equals 147. Okay, so 2 marks already achieved. The next question says, what is the square root of 36,760? Give your answer correct two significant figures. So this is looking to see that you know how to put in the square root. So square root, 36,400, I believe. Let me check. No, it's not. 36,760. 760 goes in there and I press equals. Now the first thing I'm going to want you to do is write down the whole thing on your calculator. Why? You will achieve 1 mark if you get the next bit wrong. Okay? To get the second mark, we're going to 2 significant figures. That means stop counting after the second non-zero number. So there's my first number, it's not 0, start counting. Because I've started, I carry on. So this is second, even if that's 0, it wouldn't matter. That would be my second because I've already started counting. That one is going to keep that 9 the same. That one is going to remain there. And it's 191, so this is going to change to a 0, and I can leave all of those as zeros. Okay. Next question, it says evaluate, and that just means work out, put into your calculator this number here and give your answer correct to 1 decimal place. So the first thing I'm going to do is press the fraction button, then 4.3 times by 8.6, come down here, 9.3, take away 1.4. That looks like that, and it must do. I press equals, and I'll use exactly the same idea as before. I'm going to write down the full number. Why? Because if I go wrong, I'll get 1 of those 2 marks. So that goes in there. Round to 1 decimal place means 1 number after the decimal place to put your line. That 8, if it's 5 or bigger, makes that go up by 1. If it was 4 or smaller, that stays as it is and they just disappear. Okay, so I now get 4.7 to 1 decimal place. Okay, next page, let's go to page 4. Okay, calculate the size of angles F and G. First of all, we should know straight away that F is 73 degrees. That is because these angles here are vertically opposite, okay? Now, it may ask you for a reason why it's 73, but it doesn't, so I can just go ahead and say it's 73. But the reason for that, if it was asked for, is that it is vertically opposite the 73. Okay, now notice these lines are identical, they just come straight through, so those 2 angles will always be the same. But if that sort of deviated off, it wouldn't be the case, okay, but they are, so all done so far. Then I can see a straight line here. I know angles on a straight line add to 180. So if I do 180 degrees, take away the 128, and again I can use my calculator rather than my head for having to do that, press equals, I find out that's 52 degrees. So that angle is 52 degrees. I then have a triangle. 3 sides there. So within here, this angle, and this angle, the one I'm missing, must add to 180 degrees. So what I'm going to do is add together the 2 I know, 73 and 52. Add those 2 together. 3 add 2 is 5 and 12. and now do 180, take away the 125. And again, I can just pop that into my calculator if I'm unsure, press equals, and I find out it is 55 degrees. Okay, so there were those two answers there and there. Next question. It says, fill in the boxes so that the following addition is correct. 9 add something equals 1. Well, that's not true. 9 add anything can't be 1 unless you're going to add a negative number. So this obviously is going to have some sort of carry. So 9 add 1 would be 10. You write down a 0 and carry 1. 9 add 2 would be 11. That would do it, wouldn't it? And then you carry the 1 there. Okay? So then 8 add 1. That's going to be 9. But I need to have a 4 there. So if that was a 1, that would be 10. You write a 0 there and carry 1. So it's not 1. 2 would be 11. 3 would be 12. 4 would be 13, and then 5 would be 14. So 5 add 8 is 13, add the 1 there is 14, carry the 1. So then I've got 1 add 7 add 1, which would be 9. So the answer would be 941 there. Over the page, it says a person is chosen at random. Which is the best estimate for the probability that this person was born in the month of March? Okay, well, because we're talking months, the month of March, there's only one month called March, and there are 12 months in the year, so it must be this answer here. Next question says a box contains 4 coloured cards. One card is blue, one is red, one is green, one is white. So they're all different. One card is drawn at random from the box. Which letter, A, B, C, D or E, represents the probability that the card drawn is not blue? Well, it's not blue. I had 1 that was blue and 3 that were not blue. So I've got a 3 out of 4 chance. So if I look at that line, 0 means that it's not going to happen at all. 1 means that it's definitely going to happen. C's in the middle, so that would be a half. This must be in between the two, so it's a quarter, and this is in between the two, so it must be 3/4. I've just worked out it's 3/4, so it must be D, 3/4. Over the page here, it says, the pupils at a school were asked the following question. What design would you like to have on the school badge? Dragon, daffodil, leek, or no preference? The results of the replies received are shown in the pie chart below. So I can see that the person, or the item that was most voted for was dragon. It's got the biggest part of the pie chart. Daffodil and leek both had the same. No preference there would be in second place. It says a pupil who answered the question is chosen at random. What is the probability that the pupil wanted the design to be a dragon? Well, that's 120 degrees out of what's in a circle, 360 degrees. Okay, so that would be 120 over 360. Now I can see that that answer's not there. So what I'm going to do into my calculator is press 120, fraction button, 360, press equals, it's 1/3. That option is there. So I'll just go and write down that equals 1/3, and that's why it's that answer. Over the page, number 8. In this question, you will be assessed on the quality of your organisation, communication and accuracy in your writing. That does not mean write a big long essay. It means show all your workings, use units throughout, and just give any little description that you can to any work or any question that you are doing, okay? So first of all, we're told that a task takes 6 hours and 15 minutes to complete. 2/5 of this time is spent on planning. How long was spent on the rest of the task? Give your answer in hours and minutes. Okay, so to do that, I need to go and work out how much or what fraction is left of the rest of the time. Okay, so I'm going to do 1 take away 2/5 equals 3/5. Okay, that could go into my calculator if I wanted it to. So 1 take away 2/5 equals 3/5. And this, I'm just going to explain what it is. This is how long the rest of the task takes. Okay, so I need to find 3/5 of 6 hours and 15 minutes. Now, I would go and say, well, let's find 3/5 of 6 hours. Let's go and find 3/5 of 15 minutes. But the problem is 6 isn't divisible by 5, which it needs to be in order to go and work that out. I could go and put into my calculator 3/5 times by 6, and we get an answer of 3.6 hours. And that's maybe slightly confusing. You can, little fact for you there, press this button here and it will actually tell you what it is in hours and minutes. But I'm going to show you how to do that properly, okay? What I could do then is then find 3/5 of 15 minutes. So if I change that to 3/5 of 15, I find out that it's 9 minutes. So if we go back to my previous answer, get there, add on 9 minutes to that, is 3 hours and 45 minutes. But let me show you how I would do that. First of all, I'd say that 6 hours times by 60 is equal to 360 minutes in total. With 15 minutes, that gives a final total of 360 add 15, which equals 375 minutes. Okay, notice that I'm showing my calculations. I didn't just have that pop up, and I showed where it came from, and I told what it is. It's units of time. Okay, why? Because it says in the quality, in this question, I'll be assessed on the quality of my organisation, communication, and accuracy. So rather than just having any numbers pop up, I'm showing anyone mark my work where that comes from. I now need to find 3/5 of 375 minutes. So 3/5 times by 375 minutes gives me 225 minutes. Okay, or minutes, I should write. Now, I'm asked to give my answer in hours and minutes. So I'm just going to write down here, 1 hour is equal to 60 minutes. 2 hours is 120 minutes. 3 hours is 180 minutes. Then 4 hours would eclipse that answer. So it's going to be 3 hours and something. So 3 hours and what I'm going to do is 225, take away the 3 hours but in minutes. 5 take away nothing is 5. 2 take away 8 I can't do. 12 take away 8 is 4. 1 take away 1 is nothing. And 45 minutes for the rest of the task. Okay, and I'd expect to get full marks on that question. Over the page we have got the following two-way table. A coach company runs a trip from Llandudno and Aberystwyth. The information kept by the company about the passengers on these trips includes the destination of the trip, their ages. It then says the table shows the number of passengers who went to Llandudno or Aberystwyth last Tuesday. What was the ratio of passengers 60 years old and over to the passengers under 60 years old? Just under 60 years old. Give your answer in simplest form. So let's have a look. Passengers 60 and over. Now it doesn't tell me going to a particular place. So I'm going to need to know all of these ones here and all of these ones here. So what I'm going to do is just add another column, and I'm just going to say total. And in my calculator, I'm going to do 323, add 217, and that comes to 540. Then the total of passengers here is 122, add 58, which is 180. Now I've been asked to go to the ratio of 60 years old and over, so 60 plus, colon for the ratio, 60 or under 60. So just say under 60. It's very important that the order that it's given there in the sentence is given the same here. Now I know that there's a total of 540 passengers who are 60 and over who went to the two different places. I know that there's 180 here. Okay? Now, it says to give your answer in simplest form. I can see both end in a 0. So I'm going to start by dividing both sides by 10. There and there. That gives me 54 to 18. I can then see both are even. So I'm going to divide both by 2. That gives me 27 to 9. 27 and 9 both have 3 go into it. So I'm going to divide both by 3 to get, in fact, actually, they both have 9 go into it. I'm going to divide both by 9. 9 divided by 9 is 1. 27 divided by 9 is 3. So the ratio is 3 to 1. Okay, now it's another way that you can do this is actually using your fraction button. So if I do 540 over 180, I'm just going to get the answer 3. That's because 180 goes into 540 3 times, so we could divide both by 180. If I did it the other way round, if I did 180 divided by 540, you can see it's 1 over 3, i.e. 1 to 3. So where the 180 was 1, where the 540 was 3. Okay? However, this is a nicer way of explaining it the way I just showed it then. It then says underneath, it says, one of these passengers was selected at random. What is the probability that this passenger went on the trip to Llandudno? Well, how many people went to Llandudno? Llandudno, 323 and 122. Okay, so that gives me Llandudno, I'm just going to say 323, add 122. That's definitely going my calculator, so I can't get it wrong. Is 445. It's 445 out of the total number of people. So I know that the total number of people, I could just add together the totals from before. 540 add 180 is 720. Okay? But likewise, I could have just said 445 from these two added together here, and then just added on 217, and then added on 58, and that should give me 720 as well, okay? So there's my answer. It doesn't ask me to what it is in simplest form, but I have got a calculator, so I could just go and put in 445 over 720, and that turns out to be 89 over 144, but generally, you don't need to do that, okay? Unless it says give your answer in simplest form, that answer is fine, it's the correct answer. Okay then, over the page. Question 7. Now, I've had a look around my my office and I cannot find a protractor that would help you ideally here, okay? I can show you how this is done. However, I would prefer to use a proper protractor that you would recognise. But it does say that A and B are 2 points that are 300 metres apart. Point P is such that ABP is 115 degrees. Now, the all-important thing here is that B is your middle letter. That's where we're going to do the angle. They've also put a hat on that to help me identify that. Now, that's going to be 115 degrees. So I do have a little mini protractor on this ruler. Okay, so what I'm going to do is look for 115 on this, which would be in between the 120 and the 115 there. Now, how do I actually go and use this then? So if that's 0 there on the line, I'm going to have to come all the way over here and get the 0 on the line. Yeah, this is not ideal by any stretch of the imagination. What I'm going to do is I'm going to cheat, but tell you what I would do. Okay, your protractor would go onto this point here with the centre bit there. You would then see that 0 is on the line and you come around the outside until you saw 115 degrees, which is going to be there. Okay, now initially you're going to make that mark with B and you're going to come straight through your line there, okay, and that's going to be 115 degrees accurately measured. Now the next thing that we're told to go and draw, it then says, so I've drawn that angle there. We're then told that B to P, so that P is somewhere on here, is 400 metres. The line AB is shown below is part of an accurate scale drawing. Show the positions of the points A, B and P. Complete the scale drawing to show the 2 possible positions of P. Now, what I'm going to do is measure this line here. This line, when I measure it, is a really disgusting number because of the way it's been printed. Now, I think it should be exactly dead on 6. Okay? Now, I'm just going to write down here that 300 metres is equal to 6 centimetres. Well, I need to know what 400 metres would be. So I'm going to work out what 100 metres is by dividing both sides by 3. And I find that 2 centimetres would be equal to 100 metres of this scale drawing. Well, to work out what 400 metres must be then, I could either times both sides by 4, or I could just add the two things together. Either way, I'll find out that it's 8 centimetres. Okay? Now, I know that B to P is 400 metres. So this B to P could go here. Okay? So, so I need to go and measure that out accurately now with my ruler going there. 8 centimetres. Okay, and then from here, I have got my triangle joined up, so that must be P. Okay, so go and write in there that that is 400 metres if that was 300 metres. Okay, now the problem is so far is I only have one solution. It says 2 possible solutions of P. I only have 1 of 2 so far. Okay, so where else could it be? Well, there's no reason why I couldn't have put my protractor down here and measured out 115 degrees by having the protractor down there. So coming here would be 90, so 115 would be there. Again, I'm measuring it without a protractor because I haven't got one. I don't know where mine's gone. So then I'm going to come through here and measure there 8 centimetres again to have 400 metres. P could be there. It could be that it was underneath and then down there. So my 2 possible versions of P is that I had the one up here that I've measured accurately and one down there also. Okay, bit of a fussy question, that one. Okay, over the page, this is a calculator paper, but you probably will find that you don't need it for these questions here. Something divided by 9 is 4. Well, to get rid of that divided by 9, we're going to times both sides by 9. X is going to be 36. You can chuck 36 into that and see if it works. 36 divided by 9 is 4. That's definitely the right answer. This one here, the first thing I'd recommend doing is expanding the bracket. That 4 times by the 3x to get 12x. That 4 times by the plus 2 to get plus 8. And the 12 stays as it is. We're now going to take 8 off both sides because we want to get x by itself. Okay, to do that, you get rid of anything that's not physically attached to the x because it'll make your life easier in the long run. That's going to leave us with the 12x, and that's going to equal 4. Now just be careful here. I just said we may not use the calculator, but just be sure when you stick this into your calculator. The answer here is not 3. 4 divided by 12 is actually 1 over 3. It's 1/3. Okay, so the answer there is 1/3. Next question says factorise. That means put it into brackets. Okay, so we're going to expect to see something here. That's a plus there, so I'd expect to see a plus there. Now the thing that we're looking for here is what we call the lowest common multiple, the biggest number that goes into both. Okay, no, it's not the lowest common multiple, sorry, the highest common factor even, sorry, thank you for your patience. Okay, the biggest number that goes into both. So 7 is the biggest number that goes into both. 7 times what makes 14a? That would be 2a. Let's make that look more like a 2, sorry. 2a plus 3. 7 times 3 would be 21. Here, we don't have a number that goes into both. We actually have a letter that goes into both, and it's f. F times what makes f squared? Just f. F times f is f squared. Take away f times what is f? Take away 1. Okay? Over the page, number 9. So number 9 has parallel lines. Now these lines that go through are called transversals, okay? Now it's very important to notice that these aren't parallel, so the angles with these ones will only deal with the ones that they're on that colour. So if this is 123, you can start looking for letters that we call well, we don't call them F angles, but letters that we might notice are F angles, Z angles. You might notice X as well, that's your opposite angles, or your C angles. Now C angles, the only ones where they're not equal is that they add to 180 degrees. Now, along this transversal here, I can go and work out this angle very easily. That's just angles on a straight line. So if I do 180, take away 123, I find out that's 57 degrees. Okay? Now I could then go and say, I've got a C letter here, so 57 degrees add something is 180, i.e. it is 180, take away 57, and lo and behold, it's 123. Well, that means that has to be 57 as well. Now I could have also used that A has an F angle, i.e. that angle there and this angle here makes a letter F back to front, but it still makes an F, so they must be the same. Okay, but the long and short of it, of what I want to tell you, is that along this one single line here, wherever you see 123 as an obtuse angle, will be 123 for them all. Wherever you see 57 as an acute angle, that will be 57 for them all. Similarly here, different colour line, because it's not the same as that one. Wherever I see an acute angle, that will be 74. So that's 74, that's 74. If I want to work out this one, take it away from 180 to angles on a straight line. These are all 106. Okay, so they're different in the different places, but the same rule applies to both. Now with that, I now have A is 123, I have B is 57, and I have C is 74. Question 10. This is a question on trial and improvement. Now these questions are quite timely. We're looking at 4 minutes work because it's 4 marks. You will take the entire 4 minutes to do this usually, okay? Now the first thing you're going to do is just draw a table to collect your results in, okay? So notice that my first column and my last column are very, very skinny. That's going to be x equals. This is going to be the equation that we've got given up here. And then this, well, that should say 37, sorry, and this is going to be my comment. Now, initially, a couple of things to pick out here. I'm told it lies between 3 and 4. Well, let's go and prove that. We'll sub in 3 and 4. They'll be my first two numbers. I'm also asked to go to 1 decimal place. Then it is lying to you. You actually go to 2 decimal places, but only once, okay? You only do that once. First of all, you change your x to open brackets. Now I'm just getting ready. I'm going to have it written here as well. Into your calculator goes open brackets cubed, minus 3, open brackets, and then inside the brackets, because I'm saying x is 3, 3 goes in both. Okay, so I'm going to have 3 and 3, and I'm supposed to get 37, but I get 18. So that's too small. I'm now going to change. Now rather than putting that all in again, I'm just going to change the 3 to a 4. So I delete it in both brackets and change the 3 to the 4. That's 52. That's too big. Okay, so I'm now going to try in the middle of 3 and 4. In the middle of 3 and 4 is 3.5. Okay, now I could look at that answer and say which one is closer, but 37 looks pretty much in the middle of there, so that seems like a good place to go. But you can try and cut down a little bit of work. Say, for instance, that answer was 32, then it would be much closer to 37 than 52. However, it's not, so I'm going to go bang in the middle. So 3.5 goes here. Into my calculator, just use the replay button, 3.5 and 3.5. I press equals and I get slightly over, only just, 32.375, which is too big. Okay, I now am going to go smaller. Now, initially, I'm only going to go in the counting numbers. Don't start deviating through here. Certainly don't go to 2 decimal places yet, okay? Narrow it down in between consecutive numbers that come straight after it, decimals. So we're going to do 3.4 next. 3.4 cubed minus 3 lots of 3.4. What does that equal? Make sure that looks like a 4. There we go. So I come back here, delete the 5 to a 4, delete the 5, change to a 4, and I get 29.104, which is too small. Now let me just show you where your marks come in here. I'm looking, when I'm marking this, for an answer that goes too small, too big, and these are consecutive numbers, 3 and 4. Narrowed it down, it's between 3 and 4, even though that's told I get a mark for showing that, okay? So one of my 4 marks. I'm looking again, see too big, too small. Yes. Do I give the mark? Are these consecutive numbers? Is it going to be in between those? Yes. Now, what I could do is say, ooh, that answer, 3.5, is much closer to 30. Oh, hang on. I'm not right here at all. I'm supposed to get 37. I thought I was getting 32. Stop for a second. This answer was not too big. I can't give the mark there. It was too small. I needed to make my answer bigger. Okay, so that line of working wasn't actually needed because this is too small. I needed to go to 3.6 from the 3.5. So if I come back here, change that to a 6, change that to a 6, and I get an answer that is 35.856. 35.856. Which is still too small because I'm actually supposed to be getting 37, not 32. Come over here, delete the 6. Oh, I did not want to do that. I had a feeling it might do that. I have to put the whole thing in again. 3.7 cubed plus 3.7 is, minus 3.7 is 46, 3 minus 3, 37. Okay, sorry, I'm getting a bit flustered. So I've gone wrong. I'm just trying to make it up quickly to you now. So 3.7 cubed minus 3 lots of 3.7 is 39.553. And that is too big. Right, there's my mark now. Too small, too big, come over, consecutive numbers, one after the other. Now, which one is closer to 37? They're both pretty close, to be honest. They look about the same, okay? Now, what you could do is say, I think this one is closer to 37, or I think this one is closer to 37, and I'm going to choose the 3.6, and even if that's the right answer, no more marks. I've got to go and show why it's that one, okay? So what we do is we go to 2 decimal places once. We've got 3.6 down here, and that answer is too small. Try a bigger number. So on my number line, I choose the next consecutive number, which is 3.7. And that answer is too big. So I'm going to try a smaller number. So what I'm going to do is chop that line exactly in half, which is going to be 3.65. So in my options now, up here, I'm going to do 3.65 in here. But only once do I go to 2 decimal places. I'll go and find out what this is. Oh, I did not want to do that either. Can I get that back? There we go. 3.65 goes into both brackets. That is 37.67 blah, blah, blah. In other words, then, it's slightly too big. That gives you your third mark. Okay, there's my second, here's my third. Now, I've got to choose the right one. Now, because this is too big, I've got to try a smaller number. So my solution lies somewhere between these two, i.e. is it closer to this one or closer to this one? Well, it's closer to this one, okay? If you're ever really confused by that, come to here. Whichever one is the one that is odd one out, it's that one there. So that would now give me the 4th mark, now that I've shown that line of working. If I hadn't shown that line of working, I can't get that mark, okay? Okay, over the page. It then says a biased coin is thrown 100 times. 20 throws, 40, 60, 80 and 100. Some of the results, that's my phone, some of the results are shown in the relative frequency table below. Now, we're told here the number of heads, the relative frequency. Now, to work out the relative frequency, the RF, you would do your number of successes, the ones that actually do what you wanted, i.e. your number of heads, divide it by your total number, okay? So NO for short. So let me show you where that 0.55's come from. 11 divided by 20. SD at 0.55. 18 divided by 40 is 0.45. Well, to get this one then, I want to do 24 divided by 60. Press SD is 0.4. And then to work out this one here, I just want to rearrange that. To work out your number of successes, I want to do the relative frequency times by the total number. Okay, that will tell me the number of successes. So 0.37 times by 100 will tell me that there were 37 throws of the 100. Over the page, part B says 5, 7, 8, 11, blah, blah, blah. The sum of 10 numbers is shown above is 152. We could have added that into our calculator, but they've saved us some working. Lucky us. It then says, consider the estimated mean from the table and the actual mean of the 10 numbers. Calculate the difference between these two values. You must show all your working. Well, first of all, let's work out the mean of the 10 numbers. That is going to be, add them all together, 152, divide by 10, and we're going to get 15.2. Okay? Estimated mean. Now, estimated mean, what we do is we take the midpoint. We don't actually know what those numbers are because we're not usually given our list. We're just told this table. So we take that it's in the middle. So I'm going to do a midpoint column here, which is going to be 4.5 is in the middle of 0 to 9, 14.5 in the middle of 10 and 19, and 24.5. Now, if you're ever stuck, to go and work out the midpoint, press the fraction button, add those two numbers together, and divide by 2 will tell you what's in the middle of those two numbers, so 24.5. But some people can just spot them, okay? So, the estimated mean now, I would do the midpoint times by the frequency. I'd say that those three numbers that I don't know what they are, they're somewhere between 0 and 9, so let's say they're 4.5. 4.5 times by 3, and that gives me SD at 13.5. Now, when I do actually add together those numbers, 5 add 7 is 12, add 8 is 20. So it's actually, in real life, it's actually a lot bigger than that. But that's just what my estimated mean was, because I didn't know, strictly speaking, I'm not supposed to know what those numbers are. I'm then going to get 14.5 times by 5. That's going to give me 700, no it's not, it's going to give me 72.5. Now, actually between 10 and 19, I've got 11, add 14, add 17, add 17, add 19. Okay, so if I went and looked at those, 11, add 14, add 17, add 17, add 19, it comes again a bit higher. So I've got a feeling that this answer for the estimated mean is actually going to be a bit lower than what it should be. Okay, and then finally I should do 24.5 times by 2, which is 49. Now again, 49, if I can write what I just said, 49. If I look at doing 26 add 28, I actually get 54. So it's all just lagging behind every time. So to work out the estimated mean, I want to do the value of all of the numbers added together. So that would be those 3 numbers there, divided by the total number of numbers, so divided by 10. So I get 13.5, it's a fraction button, 13.5, add 72.5, add 49, all divided by 10. That comes out of being 13.5. So as I said, it doesn't surprise me that it's slightly lagging behind. It then says, calculate the difference between these two values. So 15.2, just move down the visualizer so you can see. Take away 13.5. So into my calculator, 15.2, take away 13.5 is 1.7. And I'll just go and make sure that it's obvious that someone knows that I'm working out the difference there. Okay, so there's the difference. That's all it's asked me to do. It's not asked me to go and comment on that, but if I was, it's the stuff I was explaining before. It's actually that these numbers here, these 2 numbers are actually higher. They're actually all bigger than 4.5, which is why this estimated mean has come out low. Okay, question 16. We're going to be plotting and drawing a graph for this one, okay? So, first of all, you can see that we've got all of these numbers in, bar 1, missing 1 here. Now, just like in child improvement, we're going to change the x's to open brackets. So it's going to change to open bracket squared minus 2 open brackets minus 4. What number is going inside the open brackets? We'll go and see what the value of x is above it. 1 and 1. Into my calculator. 1 squared minus 2 lots of 1 minus 4 is minus 5. So that answer is minus 5, and that's going to go in there. It then says on the graph paper opposite, draw this graph. So I'm going to start drawing my points here. So looking at the table, it's just off screen, but I have got all of my values here. I'm just going to start reading off. Minus 3 and 11. So quite a nice scale to go through, because obviously in between 10 and 12 must be 11. Minus 2 and 4. So minus 2 and 4. Minus 1 and minus 1. Down there then. 0 and minus 4. 1 and minus 5. 2 and minus 4, we're getting a symmetrical pattern happen now. 3 and minus 1, and then 4 and 4. Okay, now this type of graph is what we call a quadratic graph, and it's because the highest power of x is squared. Now what we need to do is draw a smooth curve that connects all of these dots, and I always start at the very, very lowest points. Okay, so I'm just going to come and bring that over to the side. I'm going to start going through here. Now it's not a sketch, it's just a straight line. Okay. So a straight line that's going through all of those points like that. And I'm going to move around to the other side now and carry on doing the same thing there. And notice here I haven't stopped at the end coordinates. I've gone shooting off, predicting where I think that graph's going to go. Okay, so I'm now on to the second part. It then says, draw the line y plus x equals 4. Now what you can do for this is you can draw an xy table. Okay, so x, go and choose some values of x. 1, 2, 3 are the values that I tend to choose. Can I plot those on the axes? Yes, okay. Then y plus x equals 4. Okay, well when x is 1, what plus 1 is 4? 3. When x is 2, what plus 2 is 4? 2. 2 plus 2 is 4. And then when x is 3, that's 3, y must be 1, because 1 plus 3 would make 4. And if you look at all of those coordinates, they add together to make 4. So I now need to go and plot those in. 1 and 3, when x is 1, y is 3, there. 2 and 2, there. And then 3 and 1, there. I get my ruler, and it should go through all 3 points if I've plotted correctly. It does. So I'm going to just come there and come all the way to the side of your graph. Okay? Now you can see that my line intersects. It says write down the values, and it gives me 2 spots to write in. You can see that my graph intersects in 2 places. Here, so at 3.1, 2, 3, and 4, so that's 3.4, that's my second answer, so I'll give it second. And then this one here, okay? So I'm just going to come down and read off what our value is there. Okay, minus 2.5 would be there, this is minus 2.6. Now what I will stress to you is these are the values of my graph. Yours might be slightly different, and as long as you're accurate off your graph, you will get the marks there, okay? Okay, coming into the last couple of questions now. Not much left to go, not much left at all. Okay, number 13. Sean thinks of a number. Its value is increased by 25%. Express the number as a percentage of the... express the original number as a percentage of the increased number. Well, what I'm going to do is I'm going to think of a number. And because I'm going to increase it by a quarter, I'm going to make it divisible by 4. So I'm going to make this 100. Okay, if I increase 100 by 25%, it would become 125. To express the original number as a percentage of the increased number, it would be 100 over 125 times by 100. What you got out of the total times by 100. So 100 over 125 times by 100 gives me 80%. So that's equal to 80% of the original number. But you can choose any number here, okay? If I chose 40, increase it by a quarter would be 50. 40 out of 50 times by 100 is also 80%, okay? It doesn't matter which number you choose. Next question says, calculate the length of the side MN in the triangle below. I'm just going to move the paper up ever so slightly. Now, because I want to work out MN, that's this line here, which I might go and highlight. Now, I've got a right angle triangle here, and I've got an angle other than 90 given to me. So this should be telling you to use SOHCAHTOA, okay, or trigonometry. Now, I need to label this triangle up. That is the hypotenuse because it is the longest side of the triangle. The right angle points to the hypotenuse. This thing here, this angle here, this would be opposite, okay, so I'm just going to call that op. So by process of elimination, this must be the adjacent, but adjacent just means next to. This side is next to the angle, yes. I have got the hypotenuse. I want the adjacent. Cross out A's, sorry. I'm going to have to write out the so bit again there. Cross out A's, cross out H's. Choose the one that is double crossed out. That stands for cos angle. So I'm going to say cos x, cos angle, equals the adjacent divided by the hypotenuse. I'm now going to substitute in cos angle, cos 27, equals the adjacent, I'll leave it as adjacent because I don't know it, divided by 13.5. Finally, get the adjacent by itself. Okay, times by sides by 13.5. Into your calculator goes cos 27, close your bracket, times 13.5, and I get 12.0 to 1 decimal place. So that would be centimetres, I just referenced there, that's to 1 dp. I could have said it's 12.03 to 2 decimal places. Next question, these are simultaneous equations. There are 2 ways that you can solve this. You can either get your x's the same or your y's the same. I'm going to get the y's the same. Now I quite like it when the signs are different because when the signs are different we're going to add my 2 equations together to cancel out the y's. If I'd chosen the x's, I would have multiplied this one by 2 and this one by 5, and then I would have subtracted the equations because the sign's the same. But because they're different, I'm going to get these ones the same. I prefer doing these ones. I will always times the equation by the opposite number in front of the letter, not the minus, just the 7, okay? Here, times by 3. That's going to give me 2 new equations, and I'm going to times every single bit by 7. 5x times by 7 is 35x, plus 21y, and that is 77. 2x times by 3 is 6x. 7 times by y, 7y times by 3 is minus 21y, and then 29 times 3 it's going to go in the calculator, is 87. Now, to cancel out these equations, if you have different signs here and you get these numbers the same, you must add. Okay, so different signs equals add. So we'll do equation 3, add equation 4. 35x add 6y is 41x. Plus 21y add minus 21y is 0, they're gone. 77 add 87 is 164. Next, get x by itself, so divide both sides by 41. So I need to do 164 divided by 41 equals 4. Now I have my value for x, I can find out my value for y by subbing into one of the original two equations. So sub x equals 4 in, choose the one without the minus to make your life easier. Go into number 1. Number 1, 5x, 5 times 4 then, plus 3y equals 11. 5 times 4 is 20, plus 3y equals 11. Start getting the y by itself, take 20 from both sides. 3y equals 11, take 20, which is minus 9. Divide both sides by 3. If unsure, you have a calculator. Minus 9 divided by 3 is minus 3. Y is minus 3. Okay? Over the page here, and I believe this is the last but one, the penultimate question. A solid object is made by drilling a cylindrical hole of radius 4 centimetres through a cuboid measuring 20 by 15 by 10, as shown below. Calculate the volume of the object. Well, to do that, I'm going to start by working out a worded formula for it. So the object is equal to a cuboid subtract a cylinder. To work out the cuboid, you multiply all the sides together of the cuboid. Okay? The next thing that we're going to do is actually multiply those up. You've then got 20 times by 15 times by 10. To work out the cylinder, you work out the area of the circle here. So that's going to be pi r squared, 4 squared, times by how long it is. So times by that 10 there. 20 times by 15 times by 10 is 3,000. I'm then going to take away pi times by 4 squared times by 10. That is, well, it says 160 pi there. I can leave it as that. If I press SD, it just looks disgusting. It's much, much, much bigger. So then to work out the area, I want to do 3,000 take away that 160 pi. So much easier to put into my calculator by doing like that. Or my calculator does know that was the previous answer. So I can just say take away ands and it will still do the same math to me. So that comes to 200, no it doesn't. It comes to 2,497.3 centimetres cubed to 1 dp, which would just go there as well. 2497.3. Just check. It doesn't say to round it to anything, so 1 dp would be fine. Part B, it says the object is made from, let's try that again. The object is made from a material which has density of 2.4 grams per centimetres cubed. Calculate the mass of the object. This question. This is telling you grams, which is a mass, divided by centimetres cubed, which is a volume. So then your density must be the one on the left, your DMV here. Okay. It says calculate the mass of the object, give your answer in kilograms. So I need to do to work out the mass, I need to do the density, which is 2.4 grams per centimetres cubed. And if I look at the previous answer, which is all the way, still in my calculator, luckily, rather than having to fish through all of those, 2,4, so multiplied by, because I'm doing density times by volume, 2497.3, and that answer was in centimetres cubed. Okay, now that is going to tell me that the mass, those centimetres cubed are going to cancel out, so it's going to be 2.4 times by 2497.3. I get SD, and I get, that answer is going to be 5993.52, but that will be in grams because that bit was in grams, okay? To get that into kilograms then, I need to divide this by 1,000, okay? So I'm going to get 5.99352, okay? Oh, sorry about the mistakes at the start of that question. Hopefully that got there in the end. Number 17. The equation of a straight line is y equals 8x minus 5. What is the gradient of the straight line? Well, you should know that the general form of any equation is always written as y is equal to the gradient of x, well, gradient then x, then what is called the y-intercept. So the gradient is just purely the number in front of the x when y is by itself and it's positive. Okay, so just 8 for that one. Last question. The right angle triangle ABC has an area of 84 centimetres squared. Calculate the perimeter of the triangle ABC. So at the moment I've only got one side and there's two other sides that I need. The first thing I'm going to do is write out the formula area. Base times height divided by 2 equals area. Okay, well, what's the base? 24. What's the height? The height is always at right angles, it's always the thing that stands up, so that's my base and my height there and there. Well, I don't know what that height is, so I'm just going to leave it as h. Divided by 2 equals 84 centimetres squared. Equals 84 centimetres squared then. Times both sides by 2 to get rid of that denominator. 24 times by h equals 168. The next thing I'm going to do is divide both sides by 24 to find out what h is. So h is 168 divided by 24. H is 7 centimetres. I now have a right angle triangle that I want to know all three sides of. So that should be telling you in your head to go and do Pythagoras' theorem. Okay? Now Pythagoras' theorem I always write as a squared plus b squared equals, I always say h squared because h is the hypotenuse, but maybe a little bit confusing here because I've already used h for height. So actually let's go to c squared. C is the hypotenuse, I will label it c there. A squared is one of the two shorter sides, doesn't matter which one. 24 squared plus 7 squared equals c squared. That's going into my calculator. 24 squared plus 7 squared is, syntax error, let's try again, 625. That's now going to change to 625, that remains the c squared. I'm now going to square root both sides. The square root of 625 is 25, so I'm now finally going to make my statement that c equals 25 centimetres. So c equals 25 centimetres. From there, to work out the perimeter, I'm just going to add together all of those numbers. So add together 7 and 24 and 25 gives me a perimeter of 56 centimetres altogether. Thank you very much for watching. I hope it's been useful.